All right, greetings everyone. Welcome to the fifth part of the video now for section 6.1, trying to wrap up the information about the graphs of sine and cosine functions. Okay, so we're going to do one more example of writing the equation of a sine or cosine function, this time using a graph. Just like we did with the example we did from words, we want to start here by identifying all of the important information we can gather from the picture. So we're going to look to try to figure out what the amplitude is. We want to know where the midline is, what the period is. And then we also want to decide, is this a sine or a cosine function? And I would say that kind of like we did when we graphed these, where we started by drawing the midline, we would want to start here by identifying where the midline is. And recall the midline is something that goes right through the middle of the function. And it looks like, from my perspective, this would be the horizontal line here that goes right through the middle of the function. And it looks like that's a value of 2, positive 2. Once we have that, then we can identify what the amplitude is. So we look at how far above and below the midline the function goes, and it looks like it goes 3 units up and 3 units down. So we know that our amplitude here is 3. And the next thing we might want to do is identify whether this is going to be a sine or a cosine function. And we do that by looking for what kind of period we can identify, or what wave we can identify in the picture. And for me, if I look at this starting here and trace the graph, this looks like a cosine function, right? Because I see that starting point I chose there starts off the midline. So this appears to be a cosine function. And now that I know it's a cosine function, I'm going to look at the distance covered by that single period. So from here to here, it looks like on the horizontal axis that goes from 0 to 6. So it looks like we have a period of 6 here. Okay. And now with this information, we can go ahead and write our equation. So because we said it was a cosine function, we know we're going to use the general form g of t equals a times cosine of bt plus k. We'll fill in the information we have again. So we know the value for a, the amplitude there is 3. It's a cosine function. The value for b, remember, will not be 6. To find that value for b, we have to use the function, or the formula, excuse me, that b equals 2 pi divided by the period, which is 6. In this case, I think that we see that the 2 will become a 1, the 6 will become a 3. So on the top there, we'll have 1 pi, which is just the same as pi over 3. So our value for b will be pi over 3 t plus the value for k in this case, which was positive 2. So this is our candidate for g of t here. However, there's one more thing we need to keep in mind. We said that this was a cosine function because it started off the midline. And also notes that in this case, it actually starts below the midline. So it's been reflected vertically. So we need to put a negative sign out front. So our function then looks like g of t equals negative 3 times cosine of pi over 3t plus 2. All right. Sweet. All right. Now let's look at horizontal shifts of cosine or sine functions. And sometimes you'll hear these referred to as phase shifts. So that's why I have this here, because if you think of a period or a single wave of a sine or cosine function as being called a phase, so we're shifting the phase. And so we see that this changes our general equations for sine and cosine functions just a little bit. So If there's been a phase shift, meaning there's been a shift to the left or the right, this is what our forms will be. F of t equals a times sine of b times t minus h plus k, or f of t equals a times cosine of b times t minus h plus k. And in this case, the value of h tells us how much we've been horizontally shifted. And yeah. Now the next thing I want to point out about that is, notice here it says the inside of the function must be in factored form in order to identify what that phase shift is. So let me show you what I mean by that on the next slide. So notice in the first function here, on the inside, we have 4x plus 8. And if you're kind of following what was on the previous slide, you might think that this plus 8 here is going to tell us how we've been shifted. But in fact, it will not, because this inside has not been factored, right? So what we want to do first is actually factor that inside if we can. So we're going to make this g of x equals 3 times cosine. Notice between these two terms here, we can factor out a 4, because 4 goes into both of those. And if we do that, we can 4 times the parenthesis. Take a 4 out of the 4x, it just becomes x. Take a 4 out of the 8, we just have a 2. And now this is in factored form, so now we can use this to figure out what our horizontal shift is. And here, because we see that plus 2, remember this is on the inside of the function. Some of you who took PreCalc 1 with me may remember that means that this is inside the house of lies. So even though we see a plus 2, it's actually going to mean a shift 2 units left. Okay, not to the right, but to the left. All right, let's do a similar thing with the second one now. So we have h of t equals that 5 times sine of pi over 6t minus pi over 2, and then all of that minus 1. So we're going to do the factoring trick on the inside again. So we have 5 times sine of, we're going to factor out pi over 6. We pretty much always, if there's a number being multiplied by the variable there, want to factor that out. And so we do that, and we take pi over 6 out of the first term. We'll just have t left. Minus, and then we have to take the pi over 6 out of the pi over 2. And how will we do that? Well, notice in the top one, when we factored out 4, we were left with 2, right? So how did we go from 8 to 2 using the 4? Well, the answer is that we divided, right? When you factor, it's like dividing. So to figure out what's going to go here inside our parentheses, what we need to do is take that pi over 2 and divide it by what we're factoring out, which is pi over 6. We're dividing with fractions, so we'll keep the first one, change division and multiplication, flip the second one, so it becomes 6 over pi. Here the pi's will cancel, excuse me. So end up with 6 over 2, which just equals 3. Okay, so this should be t minus 3. Then we have the minus 1 there. And so here we see that our horizontal shift, since this is a minus 3, it's on the inside, it's a house of lies. That's going to be 3 units to the right. Okay. All right, let's look at one more example to allow us to put this all together. So here we now have a function, sinusoidal function that has been shifted to the left or to the right. And we're going to write the equation for it. And just like we did with the previous example of this in one of the previous videos, we're going to start by, identifying the information that we need to write the equation. So we'll identify the amplitude. We'll identify where the midline is, the period, whether it's sine or cosine. And then we'll also want to identify any horizontal shift, which I'll write as HS. Okay, as before, again, identifying the midline will probably be the easiest place to start. Looks like it would be right here in the middle there. So it looks like that is at a value of +1. And then we can figure out the amplitude, so how much we're going above or below that. It looks like in both cases we're going 2 units. And the next thing we need to choose is whether this is going to be a sine or cosine function. And I'll tell you that we can actually write this as either. If you recall from earlier videos, sine and cosine are actually the same wave, just shifted left or right. And so the important thing to look for would be what we can see in the picture and to choose a starting point. And when I look at this, I see that here I have a point starting on the midline. And if I trace out the graph, I can see one full wave of a sine function like that. So in this case, I'm going to choose this to be a sine function. Now again, I could write this as a cosine function. And if I wanted to, I could do that by choosing this here as my starting point and then tracing out a wave of a cosine function. But in my case, again, I think it's easier to see the sine function. So I'm going to use that. Okay, so now that I know it's the sine function, I can look at the period covered by that single wave, and it looks like it goes from a value of 2 to 22, which is a total of 20 units. So we see that our period is 20. And then the horizontal shift will come from, well, where I chose my starting point to be, which should be right here. And recall that a typical sine function starts right at the origin. Okay, that one I drew off to the side there. But here we're starting off to the right of the origin. In fact, it looks like we are to the right 2 units. This has been shifted right 2 units. Okay. So now with all that information, we can put it together to write our equation. So remember, our general form here is g of t equals a times sine of b times t minus h plus k. And let's fill that information in. So first of all, the value for a, it's the amplitude. It's going to be a 2. Here we have a sine for the value of b. Again, we do our formula with our period, so it'll be 2 pi over the period, which is 20, which reduces to pi over 10. Times, on the inside, we do the horizontal shift, and because it's to the right 2 units, using our house of lies, this should be t minus 2. And then finally, the plus the value for the midline, which is +1. Okay. And notice in this case, unlike the previous one, we'll leave the value for a here positive since the function followed the typical shape of a sine function going up first, so there was no reflection. So we see this here, this g of t equals 2 times sine of pi over 10 times t minus 2, all +1. That will be our equation for this graph. All right, that's it for now. Thank you for watching.